So number 79 is the baseball one. Okay. Information that is given. Okay, is hit from 3 feet high, and it hopefully is going to go, this is hopefully, where there's a fence right here. That fence is 400 feet from home plate, and it is, how far? 10 feet high. And I hit the ball at an angle of theta. Looks like we talk about it being 15 here in a second, but I hit it at an angle of theta at 100 miles an hour. 100 miles per hour. Okay, what's the one annoying part already that is annoying about this problem? What are all the other numbers? Feet. What's the rate? Miles per hour. Yucky. So could I, let's see, 1 mile, 5280 feet, and convert that. What else is true about, like, when you use minus 16 for gravity, what is that in? Feet per second. So I'm in, right now, this would be feet per hour. So then I need, for 1 hour, there is 60 minutes. That's still not good enough. And then for 1 minute, there are 60 seconds. Now I'm good enough. So let's see, what did anyone do that for me? What's that rate? Times 100. Lots of stuff. So that equates to 22 over 15 feet per second. So that's what we're going to use. Mini quiz tomorrow, I won't make you convert. That's just annoying. So 22 over 15 feet per second. And the whole question is going to be, it's definitely going to turn into a parabola when you hit the ball. It's going to be free falling right after you hit it. It's going to be the shape of a parabola. The key to it is, does the parabola clear? The whole key is the parabola has to clear the point 400, 10. Okay? So first thing, it wants parametric equations. Okay, so there's an x equals and a y equals. The y equals is the one you've spent more time with, and that is negative 16t squared plus v naught t plus c. Or maybe did I write h? I used to write h naught. What did I write? H naught. Okay. Now, a lot comes from this triangle, and this portion there is the only part that is the vertical y. Yeah. Oh, so real quick, everyone who's listening, this is not 22/15. It is something else. What is it? 440 over who? 3. 440 over 3. Okay, sorry about that, guys. So for this would be negative 16t squared plus. Now the initial velocity is the red portion of the triangle, which is, let's see, it's going to be the sine call. Remember, this part here is the 440 over 3. That is the rate or the speed at that hypotenuse route. So I only want the red part, which would be the sine component of it, which would be 440 over 3 sine of theta. So that's going to be the v naught part, 440 over 3 sine of theta t. And it started at 3 feet high, so plus 3. Okay. For the parametric part of the x, assuming no air resistance, that means whatever the initial velocity of the x is, and let's say I do that in green, the initial velocity of the x is going to be that times time. That's it. So x is v naught t. So x would be not the sine component, but the cosine component. So 440 over 3 cosine theta times t. And this is cosine of theta times t, just like this is sine of theta times t. Okay? So it wanted the parametric form of this, and I have it. From here, could you graph it immediately on your calculator? Okay, and you could see it parametrically, and you could see the parabola, and then you can kind of trace out, and the whole key again is you need to beat 400, 10. So you need to make sure you go 400 feet, and then you need to make sure when you hit at 400 feet, are you at least above 10 to clear the fence? No. So that's why it said on part A, write a set of parametrics. Now let's graph it using theta is 15. The big thing is you can't, more powerful calculators can do it with the two variables, but we're always going to have to play around with the cosine or the sine. Okay? So part B says, let's make theta 15, and let's check and see if it's a home run. Then let's do theta is 25, and then let's check. And then the big part is D, is the one that I care about. Okay? So from the back of the book or whatnot, did you hit a home run? Was it a yeah? No? Was 25 a home run? Or 23. Okay, yeah. So you checked theta is 15, and this was a no. That means you did not go 410 plus. That means you might have been short. Do you guys remember, were you short, or did you go 400? You guys remember? Okay. So all it means is maybe you did something like this. You could go to 400,8, and that's short. You hit the fence. Or maybe you only went to 370,0. That means you hit way short of the fence. But you did not clear the 400 and the 10. And then apparently the next part was theta was 23, and it was a yes, it was a winner. But we don't want to just play the game of checking when, let's try 16, let's try 17. We want to try and do it by solving with algebra skills. So, here's what I would do. We have to use these guys, and we need to solve. And we need to solve for theta. For a perfect home run, do you agree if I go 400 feet and 10 feet up, do I hit the very top of the fence? So if I increase it just a little bit, should it clear the fence? So the whole key is, let's force this to happen. We are going to force the ball to land exactly at 400, 10. So that's my x, that's my y. So right away I'm going to say 400 equals 440 over 3 cosine theta t. And I'm going to say 10, that's my y, is negative 16t squared plus 440 over 3 sine theta t plus 3. How many equations do I have? 2. How many unknowns do I have? 2. Is that solvable? Okay? So I'm going to hit pause. You guys can go to boards or whatnot. I want you to try and solve this, okay, if you haven't already. Go to board, solve it. I'm going to solve it and just not waste tons of video space. So solve, and then we'll come back in a couple minutes, okay? Okay. So in solving, I told you we are going to force the ball to be exactly at 400, 10. So I set 400 equal for my x and 10 equal to my y. You have 2 equations, 2 unknowns, those 2 red equations. You can do a substitution style. So in my mind, since both guys have t, I'm going to sub for t. If both guys had if both guys had cosine theta, could you replace cosine theta? But since one guy has cosine and one guy has sine, you would have to replace the theta part, which would mean you'd have to have an inverse cosine or an inverse sine put in. Yuck. So all I did was, I'll start drawing arrows. From here, I solved for t. I sent that into the y equation. right here. And wherever I saw a T, I put in my green T. Haha, green T. Like, okay. And I solved. Now, the part I simplified a little bit was here was kind of nice. Lots of things canceled there, and you only got left with 400 tangent. The other stuff didn't come out as nicely. This stuff here was kind of ugly. But you can say, once you simplify down to, you could have done it right here if you wanted to. Right here, could you say 10 is y1 and the other guy is y2 and find an intersection? I just simplified down just a little bit to here. I'm going to say 7 is y1 and this whole right side is y2. Find the intersection. Okay, so graph them and find the intersection. Now, I actually found two intersections. I found 19.4 degrees and 71.6 degrees. There's actually infinite amount of intersections, but there's only two of them that are between 0 and 90 degrees. That means if you hit it at an angle of greater than 19.4 or less than 71.6, you're going to hit a home run. The options here, just so you visualize it, here's 3, here's way over at, let's call this 410. The 19.4 one would be kind of like what Cargo did yesterday for the Rockies. He hit a line drive that barely cleared the fence for a home run. So that would have been the minimum angle. This is 19.4 degrees. That's basically a line drive home run. The other one would have been a sky ball. So the other one would have been at 71.6 degrees. It would have gone like this. Woo! And just cleared the fence that way. And all other home runs that are in between 19.4 and 71.6 would have done something like this. Something in between would have cleared the fence with more oomph. Okay, it would have landed deeper into the stands. But the green one would have barely cleared it. The blue one would have barely cleared it, and anything outside of that would have hit it further, basically. You guys okay with that? Okay? But the whole question said, which angle is the minimum? 19.4. And the whole key to it again was coming back up to the red here and going, okay, two equations, two unknowns. The key was you forced it by saying, let's just barely hit the top of the fence, and then you can play the game of what do I need just a little bit more of to make the home run. Better? Okay? Cool. Other big questions? Are you guys doing okay with the parametric stuff and just trying to visualize what it looks like? So let's do this just for more practice. I'll hit pause on the video, but let's try, let's do some even problems from the book. I'd like to try 8, 12, and let's do 22, 8, 12, and 22, and yes. Try those three out real quick. You guys that are juniors, you could try these out too if you want, or just, I don't know, do something. So I said try 8, 12, and 22. So here's 8. What I first did on 8 is I'm going to solve for a t and substitute it in. Okay, you can do either way. Normally I try to sub in for the x part because then it's going to get a y equals. If you try and solve the right guy here and get t equals y here, if you do t equals 8 minus y and you sub that in, you're going to get an x equals, which is fine, but we always normally like a y equals, so I won't do it that way. So I solve, I get t is x to the 4th, plug it in, y equals 8 minus x to the 4th. I drew that. Do not look at any of the yellow, if that's possible, and just stare at the blue. 8 minus x to the fourth in blue is the path. That's the rectangular story of I-25 like yesterday. That is what the road is. Parametrically though, I want to have a start and end and where did I drive? How did I drive? So the big thing parametrically is all the yellow, and I stare at that and I get x equals the fourth root of t. What can t be? What does t have to be? Positive or 0. So because of that, t has to be 0 or positive. So I physically plug in 0. Fourth root of 0 is 0. 8 minus 0 is 8. So I start at 0, 8. Then as time runs to the positives, everything falls to the right. So parametrically, it is not the whole parabola. It is only the right side of the parabola where you start up top and then you fall down. You guys see the difference? Again, I-25 is the road, and my story is the truck started at 0, 8, and it went down I-25, and it just kept going down. Okay, so that was number 8. Number 12, I just told you on the previous one I would normally solve for t and the x guy and throw it in, but I do not want to deal with absolute value. So this one I actually solved it with the y one. So t is y minus 2, x is y minus 2 minus 1, which is x equals y minus 3. You know that one really well if it's y equals x minus 3. Which way do you move it if it's y equals x minus 3? 3 to the right, or 3 to the positive. So if it's x in terms of y, I need to move it 3 to the up, or 3 to the positive. And it opens up like a V to the right. The blue part, that sideways V, is the path. And I want to know how the truck drove on the path. And I look back at the things. Now I'm focused on yellow. There's no issues. You can plug in any t that you possibly want. So if I plug in t as 0, I get 1, 2. So I plotted that over here just for my sake to see. If it was negative, guys, it's coming from the bottom. If it's positive, it keeps going up. So this story is the truck went from forever down low, and it went forever up top. Okay, and it went in that direction of arrows. Okay, so that's 12. 22. This one should scream it's going to be a conic. It's going to be a hyperbola or circle or an ellipse. The reason I focused on saying it probably is going to be a circle is because it's 3 cosine and 3 sine. They're the same number in front, so that should equalize it. You could solve for theta, okay? Just like in the last two you solved for t. I wouldn't, though, because it gets you the same answer, as we found out. It's just a little bit more algebra. Instead, I would solve for cosine squared plus sine squared equals 1. Use that identity. So to do that, I got cosine equaled and sine equaled. I already know if I square those equal 1, so I'm going to square those two fractions, and they have to equal 1. And I would do one little simplifying. 3 squared is 9 for both of them, so you can move the 9 over. That means I have a circle centered at -2, -5 with the radius of 3. So I drew that, and that's the blue circle. That is the path. So it's a NASCAR race, and it's a circular track, and they just go around and around and around. But you want to know where they start and which way they go. There's no issues with theta, so I'm just going to randomly plug in points. Is it smart to plug in 1, 2, 3, 4, and 5? No, because you don't know cosine of 1 or 2 or 3 or 4 or 5. But you do know tons of cosines and sines of pi's. So I'm going to plug in 0 and pi over 2. When I plug in 0, I get negative 1 for 5. I get 1 for x and -5. So I started there. Then plug in one more guy just to see which way it's going. So I plugged in pi over 2, and it happened to be up top. So I'm pretty safe to say that it goes counterclockwise, and that's the path, the route that the truck takes. You guys okay with that? That's a -2, -2. Sorry. Wink. There we go. You guys okay with that? Okay? Better? Let me just make sure that is -2, -2. If you plug in pi over 2 here, sine of pi over 2 is 1. 3 of those is 3, so -5. Yeah, -2. Okay? What's up? Yeah, I would just say, wherever you put the start, you might want to say, this start is me defining it at theta equals 0. Okay, you could say, I want to start at 3 seconds ago, and then you would say, start is at theta equals -3. A lot of times on a word problem or something like that, they'll say, like the baseball problem, the time starts when you hit the ball, so that is time 0, and then you know. Okay? All right, so I'm going to end the video here, and you guys can open up the next video, and that will be starting our notes.